Hello, beautiful people. Today we're talking about 8.1, which is testing the difference between means. We're going to be able to tell whether two samples are independent or dependent, and then we're also going to be performing some two-sample z-test, and then we'll make some determinations based upon that. A two-sample hypothesis test is going to compare two parameters from two different populations, and then with that, you're going to have independent samples, and then you're also going to have dependent samples. Independent samples are samples that are not related. So like if I have one sample, it's not going to be related at all, not related to the other one. Those are independent, we're not related. Dependent samples, paired or matched samples, this is when each member from one sample corresponds to a member of another one. So for independent, they're kind of just random dots. This one has 4, this one has a different number. For dependent, you want to make sure that they match. So one will always connect to the other from sample 1 to sample 2. So we're also going to be talking about some hypothesis testing. We're going to have H null, and then we'll have our alternative hypothesis as well, the null hypothesis and alternative. The null hypothesis will still have the less than or equal to, or greater than or equal to. So you're looking for the equal to sign. The alternative is still going to be less than, greater than, or equal to. The other thing, though, the new part of it is this no difference part of it. You are assuming that there is no difference between the parameters of the two populations. No difference. For the alternative, you're going to just always think that the null hypothesis is false. And then this same chart that you've had before, so I'm not going to go into that one too much. But one thing that you can see here, regardless of which hypothesis you use, you will always assume that there is no difference between population means. Always assume that the population mean for one is the same as the other. So here's some more information for you. Gets a lot because you have all these different formulas and whatnot, but I'm going to tell you now, in order to do this by hand, you would end up subtracting each of these. But what we're going to be doing is, because it's more convenient, we'll be using technology. So make sure you have your TI 84 for this lesson. It'd be kind of helpful. These are the steps in which we're going to be doing things. So not very different from what we've done in previous sections. The only difference is we're doing a 2 test instead of a 1 test. The other thing, from previous lessons, you kind of have seen this before. Maybe you forgot. Maybe when you take your next assessment, you want to make sure that you have this in one spot as well. But this is with regard to the p-values. So if p is less than or equal to the alpha, then you will reject the null hypothesis. And if p is greater than the alpha, you will fail to reject the null hypothesis. Then these were just some key things that we needed as well. If you'd like to highlight them, star them, whatever you need to, but make sure that you kind of have those. So if you could please take a moment, press pause, read sample A and sample B, the samples for each of those, and then determine which ones are independent and which ones are dependent. And then don't forget, when you're trying to determine that, you're using these as guidelines. For independent, they're not related to each other. And then for dependent, they're kind of paired or matched. So there's definitely some dependence there. Okay, so I said dependent for the first sample because you have the weights of 65 college students before their freshman year and then the same students, the same 65 students after. So they're kind of paired and they're kind of matched. So I might compare my weight before and then my weight after. That's going to be dependent. And then for the second one, I said that it was independent because they are not related. You're using 38 adult males and you can't match each of them with 50 adult females. So that one I said was independent. I would say that yours for your next project will likely be independent. Okay, the next part, we're going to look at some technology uses here. Example 1, use the TI-84 display to make a decision to reject or fail to reject the null hypothesis at the given level of significance. Make a decision using the standardized statistics and using p-values. We'll probably just use p-values for this one because I think that's what we don't use as much. I think we're getting really comfortable with the z's and forget about the p's. So from the previous sheet of paper that you have, you found that if p is less than or equal to the alpha, then you will reject the null hypothesis. And then you found that if p is greater than your alpha, then that's when you will fail to reject. Okay, I don't know, pen issues. So what's the p? Well, the alpha here is 0.01, so 0.01. And the p, if you're looking at your chart here, is 0.03. I'm going to go with two numbers after decimal point. So how do you compare these? This is your p, this is your alpha. This one is obviously greater than that. And so I'm going to fail to reject on this one. Fail to reject. Okay, so example 3. Now I'm going to show you how to get to this screen, basically, on your graphing calculator. So if you have that, go ahead and get it turned on. And if not, go ahead and grab it really quickly. Otherwise, you're just going to follow along. But the steps that we're going to be doing are all right here. So this should kind of be like your guide. So example 3, test a claim about the difference between two population means, mu1 and mu2, at the level of significance alpha. Assume the samples are random and independent, and the populations are normally distributed. That assume that they're giving you, those are requirements. It has to be that way. If it's not, then you can't do any of the stuff that we're doing here. If convenient, use technology. So this right here is saying you can do everything that we just showed you how to do. So for part A, looks like your claim is that the population mean for 1 is greater than the population mean for 2. Your level of significance is 10%. Population statistics are given, and your sample statistics are given. So a couple things. This is your population standard deviation for 1, your population standard deviation for 2. Sample, this is with regards to your sample. So your sample mean was 500, and your sample size was 100 for that one. And then for the second one was 495 in there. So I'm going to do this. Yes, I'm going to have you go ahead and enter this in, but a moment I'm going to write down this information in the order in which you're going to be entering it in. So once you go ahead and press stat and then hit the arrow to the right twice to get this test, and then some calculators you can just hit left and you get the test. Then you hit number 3 and you know that you're in the right spot if it says 2 sample z test, and then you want to enter stats, not data. Okay, so in the order in which for your calculator that you're going to be entering these numbers. This is where I'm getting them. Your standard deviation for 1 was 40, for 2 is 15, x1, n1, just going all the way down. This is what you'll do. And the claim is that the mean 1 is greater than mean 2. So make sure that you are hitting this option when you do it, and then you're going to hit calculate. You don't want to draw it. You could if you wanted to, but no one really cares. Instead, go ahead and calculate that. And when you do, you'll find that the p-value is 0.13. 0.13. Well, 0.13 in comparison to what was my alpha for this one, 0.10, is greater than that. So I'm going to fail to reject again. So go ahead and write that. You're going to fail to reject the null hypothesis. All right. So really quickly, in words, not enough evidence to support the claim at a 10% level of not confidence, but significance. Excuse me. Okay, let's keep it pushing. Wonderful word problem. Okay, so here we are with example number 4. You want to buy a washing machine, and a salesperson tells you that the mean repair costs for model A and B are equal. So it sounds like they're saying that the mean for 1 is equal to the mean for the second. The mean repair cost for 24 you decided to do some research, and so here's what you have found. The mean repair cost for 24 model A washing machines is $208. So this 24, that tells me that the sample size for 1 is 24, and I found that their mean for sample 1 is $208. And then you're going to assume that the standard deviation for that one is equal to 18 bucks. That's for the one only. You can go ahead and, as I read, write down the same stuff, but do it for Model B. So the mean repair cost for 26 Model B washing machines is $221. Assume that the population standard deviation is $22 for that one. At a level of significance of 5%, can you reject the salesperson's claim? And then you're going to make the same assumptions that you did before. So for Model B, this is your information. Your sample size is 26. Your sample mean is 221, and your standard deviation for the population was 22. Check that right up here, because this is X bar instead of mu. This is my bad. Okay, so it looks like the first thing that I would like to do here for part A is identify the claim and state the null hypothesis and the alternative hypothesis. So go ahead, let's do that really quickly. So remember that your null hypothesis is the one that has the equal sign, and here's your claim right here. They're claiming that they're both equal to each other. So mu1 equals mu2. The alternative is going to be that they are not equal to one another. And this one is their claim, so I'm just going to write claim in parentheses instead of writing the whole sentence out. Part B, find the critical values and identify the rejection regions. So I'm looking at my alpha for this one, and it was 0.05. So from here, you're going to go all the way up to the, or actually back to that other sheet of paper, and it tells you that for a 0.05 with a two-tailed test, your z-score, is going to be positive and negative 1.96. So if I'm looking at this, I have positive 1.96 and negative 1.96, and these are my rejection areas. Reject the shade. Okay, part C, the next thing, or another way to say that is z is less than, so anything on the left side of that, negative 1.96, and anything greater than 1.96. So part C, find the standardized statistics. So I'm going to have you do the same thing you just did for the last one, but I want you to use the actual data from this one. So that's your X bar for the 1, and then for 2, and so on and so on and so on. Let's enter all of that into your calculator, please. So if you didn't press pause, go ahead and press pause now. Make sure that you get these numbers. If you're having some technical difficulties, just make sure that you check with a neighbor to make sure that you're all right with that. But when I entered in all of this information, I got z is equal to negative 2.94. So looking at that in my wonderful little graph here, negative 2.294 is way out here. It's in my rejection area. So I'm going to reject the null hypothesis. So what does that mean? So my interpretation is that there is enough evidence at the 5% level of significance to reject the claim that the mean repair costs for Model A and Model B are equal. Thank you very much, and now it's time to do some work on your own.